Good morning, everyone. Welcome to day 2 of SEMANTiCS. We hope you enjoyed yesterday, the presentations and the evening. What happened yesterday? A lot of nice talks. And we are sure that you are going back after today with a lot of insights. These graphics are made by an artist who's joining us online and drawing by listening to the main talks, and she has made those graphics for the research and innovation papers. What we have online on social media is lots of good content. We have big plans for SEMANTiCS, so I would really appreciate if you can spread the news. What happened yesterday, those are part of our tweets. It would be great if you can share with your network and with hashtag SEMANTiCS and following our Twitter and LinkedIn. I think it's closed the group, but please send requests to join. What's happening today is we have a keynote, we have invited talk, a panel, and of course, closing ceremony. At 4:15, would be also great if you are staying that long to join. But right now, so we are switching to our keynote. Aidan Hogan, I hope I pronounced it well. Aidan is Associate Professor at the Department of Computer Science, University of Chile. We are grateful that you took this effort and came here. I'm a big fan of your research, following it for many years, and I'm sure many in this room. He's the Executive Director at the Millennium Institute for Foundation Research and Data. His research interest relates primarily to semantics, knowledge graph, information extraction, and reasoning. He has published over 100 peer-reviewed works on these topics. He's an editor-in-chief and co-founder of upcoming journal Transactions on Graph Data and Knowledge. And he's the author of 3 books. The latest one is called Knowledge Graphs, and the link to access it is in his bio in the SEMANTiCS. Aidan, the floor is yours. Thank you very much.
Okay, you can all hear me. Thank you very much for the kind introduction, and thank you very much for the invitation. It was a long trip to get here, but I'm very pleased to be here. So I guess as you look at the title, I know what many of you are thinking. Finally, somebody is going to be talking about language models and large language models in this conference. So we've heard a lot already about knowledge graphs. We've seen some great talks that have spoken about knowledge graphs and about large language models. So I hope to bring I will be repeating some of the messages we've already seen. I'm hopeful as well I can bring a unique perspective to the topic. So what is that perspective? Essentially, this one. My area is the semantic web. I've been doing research on the semantic web since 2005, 2006. So I've been thinking about these problems with the semantic web for a long time. I would consider myself an expert on the semantic web and knowledge graphs. I would consider myself less of an expert on language models, large language models. And the story I'm going to tell is from that perspective of looking at large language models from the perspective of someone who knows a lot about knowledge graphs and trying to figure out what all this means. So in my course, I teach a course in the University of Chile called The Web of Data. And I try to motivate the students and tell them why they should take the course in the first class. So I tried to motivate some of the ideas behind the semantic web. So I wrote this book, The Web of Data. And I use this example primarily in my class, in the course. So we have a literature student, and she is interested to find Nobel laureates in literature who have fought in wars. And from the list, she would like to find out the year the war started and so forth, right? So how would you do this on the web currently? You could type this into Google. You could type in, find me Nobel laureates in literature who have fought in wars, and what will Google give you? Not a whole lot of help, right? Because nobody has put all that information together on one web page. Yeah? So this is a classic example. So here we have the HTML, and we describe somehow the structure of the web in the class, and we don't need to get into that now, but we have these formatted documents, we have these links between these documents, and this creates the web that we all know and love every day. So using this, we can then essentially answer questions, for example, as people who understand English, what Nobel laureates fought in World War II, and we have William Golding, for example, the writer of Lord of the Flies. However, what students don't really get sometimes is why this is difficult to process natural language. So what I like to do is I like to mix things up a little bit. I just do a one-to-one mapping of all the letters. It's the exact same content from a machine perspective. It's isomorphic, right? It's a one-to-one mapping of the letters in the language. But what it does is break our connection to what this means, yeah? Now it's just gobbledygook to us, yeah? So I leave the numbers here because essentially machines have some understanding of numbers. They can add them and subtract them and so forth, so they're not completely opaque. But if I ask you now this question, what's the answer? So it seems the animation's not working, but I swapped the laptop, but the answer is nugsu neg o, right? So this slide, I think, captures the difficulty of processing natural language. Once we break this connection and we look at this and we try to think, how are we going to write an algorithm to answer these sorts of questions over this sort of content, we get an appreciation for why it's difficult to build algorithms, models, machines, systems that can incorporate the content of the web and answer questions across the web. Yeah? So the students are maybe mildly convinced by this example when I present it to them. So this, how do we solve this? On the semantic web, the way we've been working for a long time, the paradigm we've been following is that of structure and symbols. Yeah? So we hear about symbolic approaches. So we say we need to structure the content of the web in order to make it machine readable. Yeah? So what does it mean? This is essentially a knowledge graph. What I've done is removed all of the symbols, so it's somehow similar to changing all the letters in the English language. So the symbols, if you're into astrology or maybe astronomy, you might recognize these symbols. You're not supposed to. They're just supposed to be random symbols. We have no idea what this graph is about, much like the machine won't know. It's just some symbolic representation, a knowledge graph, an RDF graph, whatever it might be. And now we have this question that follows the same structure as the graph here. Yeah? So can anyone see what the answers might be? Let me explain a little bit more detail. These are variables. So we'd like to map these two variables here into symbols in the graph such that we create a subgraph. Yeah, it maps into a part of the graph. So does anyone see where P is going here? We need to satisfy all the other symbols, right? So if we look here, we have this sort of, let's say, 4 symbol. So it seems to match here. And we have this M symbol, which seems to match here. So it seems to be matching this part of the graph here. Yeah? We don't need to understand what's going on, and it doesn't seem difficult to build an algorithm to do this. Yeah? So we can do this, and this is query processing, this is join processing, or this is graph homomorphisms if you're from the more theoretical or graph theory community. So here's the matching. We have A somehow matches to this symbol here, and P matches to this symbol here. I hope you can see why, because all the other symbols match. And we get our answer. Again, from the machine perspective, we have no idea what we just queried for. We have no idea what data we did it on, and we have no idea what result we got. Doesn't matter, right? So where does the meaning, where's that interpretation applied? Well, we'll see that in a second. In reality, the symbolic approach, what we might see is something like this. We're not going to see weird astrological symbols. Yeah, we're going to see Q something, P something, which we might recognize, or many of you, I guess, might recognize as Wikidata. Yeah, so we get some answer here, and this is essentially what it would look like in reality, these symbols. Yeah. So if we try to interpret this, and maybe we search for labels in Wikidata to figure out what all these symbols mean, these Qs and these Ps and so forth, really what it means is the following. We've just queried over this graph here using this query, which is in the same structure as the graph. And we've found out we've gotten some results for people who've been awarded the Nobel Prize for Literature. Yeah. But we can also do much more complex queries. This is a relatively simple query, just to be concise. We can create much more complex queries, such as the one I originally started with, find me Nobel laureates in literature who have fought in wars the year the war started and so forth. It's a little bit long and so forth, but you can run that on Wikidata and you get about 50 answers. Yeah? So here we get our answer, and it's us humans, we take these symbols and we give them some sort of interpretation, maybe with the help of human annotation, of labels and so forth. So I teach this to the students, and I tell them with this symbolic approach, we can actually get answers from across the web. And there's a lot of assumptions that go into that, but essentially, if we structure our data, we apply this symbolic approach, we can build algorithms that can do more than what we can do currently with natural language. Yeah? So many of you are familiar, hopefully you don't need too much convincing about this in the SEMANTiCS conference. In terms of not only queries, we can also apply symbolic approach for representing semantics. Yeah? So what I have here is the same graph with their symbolic approach, and this time I have rules. So I have this, the body of the rule here, this is the premise I want to match in the graph, and if I match this, I want to come to this conclusion here. Yeah? So we have this weird P symbol with a line underneath, and we see if X, whatever the symbol is Y, and Y the same symbol Z, then we can entail X, that symbol Z, which we're encoding the semantics of transitivity. Oh, switch. Oh, yeah. Okay. So what are we encoding here? In terms of human intuitive semantics, we're encoding transitivity of a certain property. Yeah? What is that property? We don't care as a machine or as in the symbolic approach. So what do we do if we apply this rule? And this could be an ontology, we could look at the same thing. We're going to infer, because we have this sort of chain here between these symbols, we're going to infer the same relation here. We're going to take these two relations here for P, underlined. We're going to connect these two symbols here. Yeah? What do we just do from a human perspective? If we actually try to interpret this, we just essentially define the transitivity of the part of relation. Yeah? We don't know anything about this in the symbolic approach, but we've just represented it as such. Okay, and in this case, we can infer the Normandy landing was part of World War II through the transitive property of part of. So, what is the problem with the web? In the book, I talk a little bit about the difficulty of natural language processing, the difficulty of getting automated methods that can understand text, that can understand this sort of content. I took this one particular example that we're going to return to. So there's some detail in terms of trying to explain what are the difficult kinds of tasks in natural language processing. One of them is co-reference resolution. And the goal, again, is to motivate structuring the web to avoid these sorts of difficulties. So you see this example, which is essentially a co-reference resolution problem. We're going to compare two sentences that look very similar. We're going to look at the first sentence. Jane tried to follow her late grandmother's recipe, but she had not included details of the cooking times. Versus Jane tried to follow her late grandmother's recipe, but she had forgotten to buy lemons. And the question is, who is she in this text? Yeah. For people maybe who are not native English speakers, when I say late here, I don't mean late in terms of time. I mean passed away, has died, just in case. That's an important clarification. So after all of this motivation and saying how difficult it is for natural language processing and how difficult it would be to have automated methods interpret this sort of content on the web, now we have ChatGPT, we have these large language models, and it seems that actually it's not so hard after all. Yeah? So I was wondering if the examples I had written in the book held up. So the book was finished in 2020 during the pandemic. I was suddenly very productive because we were locked down in an apartment in Santiago. Plenty of time to finish the book. So then now we have ChatGPT, and I was interested to see somehow if these examples held up. So this should be animated so I can reveal it one by one, but that's also okay. So Jane tried to follow her late grandmother's recipe, but she had not included details of the cooking times. Who forgot to include the cooking times, Jane or her grandmother? What do you think? The grandmother. Yeah, so we agree more or less. We're satisfied with this response here. Yeah, this was the very first thing I tried on ChatGPT. You all probably tried your own things. I don't know what you asked. Maybe you asked about yourself, or you asked some interesting question. There's quite a few people in the back as well. Maybe there's some space over here. Do feel free to move around if you want to grab some seats. It's fine. And if you can make space for people to come in and sit down, that would be good. So in the second case, we have who forgot to buy lemons, Jane or her grandmother? Who do we think in that case? Jane. Yeah, we can more or less agree. It's not like some sort of logical implication, but we can, from context, tell that the person who's making the recipe probably forgot to buy lemons. And this impressed me. I was like, wow, okay, this is interesting. I tried more because I thought, okay, that's a 50% chance the first time, and then, okay, it's a 25% chance, and then it was a 12.5% chance, and it continued getting it right. I started creating more examples. So I then wanted to see what kind of reasoning or how is it getting to this conclusion. So I was wondering, does it understand the premise here? So I asked ChatGPT why was Jane's grandmother late, and ChatGPT told me that I had been very unkind and not getting it any information as to why the grandmother was late. Yeah. And then I specified, well, actually, this should be grandmother, passed away. So why was she late? And again, ChatGPT was very confused by all of this. Yeah. So of course you might say, okay, what about GPT-4? So that was with GPT 3.5. So asking GPT-4, GPT-4 understood the context and understood what was going on and what I meant by late grandmother. Okay. So what I'd like to do is to maybe talk a little bit about, before we move forward with knowledge graphs versus large language models, a little bit about the past. Yeah? Because I read some interesting stuff, I saw some interesting talks about large language models, and they discussed some parallels that we had seen previously in the past. I'm just realizing a slight issue, which I copied a slightly older version of the slides than I had hoped, but that's okay. Is it? Yeah, it's okay, it's fine. So, okay, we can start with this proposal. This is a proposal. Has anyone seen this proposal before? It's quite famous in the artificial intelligence sort of area. It was thought to be like the start of the artificial intelligence as a discipline. So who do we have here? We have a couple of names that you might recognize. We have McCarthy, Minsky, Rochester, and Shannon. Yeah, so these are pretty famous names. These people decided that they wanted to build machines, a machine that would basically be able to emulate human behavior and human intelligence. So in 1955, they proposed this workshop. What we call a workshop now is maybe 3 days or 2 days or 1 day or maybe a week. These people wanted to do a 2-month workshop. And they wanted to work specifically on the problem of what they called artificial intelligence. Yeah? And they believed that we think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work in it together for a summer. So, pretty busy summer they had planned, right? So it's interesting going through this. If you look at the topics and the themes they were discussing ideas like automatic computers. They were talking about the speeds and memory capacities of present computers may be insufficient to simulate many of the higher functions of the human brain, but it's somehow they're saying, well, we should try to make do with what we have and see how far we get. Yeah? They're talking about how can a computer be programmed to use language, and they believed essentially that there's rules of reasoning and rules of conjecture. They thought the human mind was a very logical endeavor, and we could, apply logic and rules and figure everything out. They also spoke about neuron nets. There were some already proposals of some sort of early neurons, artificial neurons and so forth. So they were talking about exploring this and saying that more work is needed and needs more theoretical work, effectively. And they were talking about self-improvement. They were talking about randomness and creativity, this idea that creativity was basically logic, and then you insert some randomness, and creativity comes out, yeah? And so forth. So this was quite... how would I say it? This was quite, it's interesting going back to this document and looking at it from the perspective of what we know now, because you see many of the same ideas echoed in 1955. So another major paper was soon after in 1956, I think, which was one of the first papers on machine translation. There had been some works before, but essentially they were trying to translate from one natural language to another. So Jacob, the author of this paper, what he did was he took 10 English sentences, 10 Russian sentences, and he tried to define an algorithm that would translate those 10 English sentences to the Russian sentences and back. Yeah? So in that stage, this is essentially the algorithm, right, and written in sort of a flowchart, natural language sort of setting. So really, if you look at it, he believed that somehow he could write an algorithm, I don't know, maybe 10,000 lines of code or something, to translate like between natural languages, in this case between English and Russian. This was one of the first chatbots that caught attention from people. When was it written? It was written in 1966. Yeah. So it was called ELISA, and we can try it. Do you want to try it? Do you want to try a chatbot from 1966? How do I? Hopefully this works. Somebody has prepared a mic for me. Can you hear me? Yeah. Okay. Well, hopefully it's not a problem. Hi, Eliza. Oh no, I've never seen this before. This keyboard is quartz, not QWERTY, it's quartz. Okay, I'm gonna be a little bit slower, but okay. I am giving a keynote. And I am slightly hung over. Do you believe it? I'm Irish. I'm sorry for all the Irish people. I'm playing into stereotypes. Sorry, Ed. Can you elaborate on that? Irish people drink a lot. Yes. Yes. Okay, so I think you get the idea, yeah? So this was a chatbot written in 1966. What's going on here? We had a pretty good session. We had a pretty good session. It's random. You can try it. There's lots of implementations. That was an implementation of what was done in 1966. So there's a few of them available. So it was quite convincing. I mean, we're maybe a bit more used to more advanced sort of, responses and so forth, but it's using a relatively simple trick, which is that it's based on a mock Rogerian psychotherapist. So what does that mean? Basically, there was this idea that therapists could essentially give you therapy just by asking you follow-up questions and making you work through and explain what's going on. Yeah, so it's sort of just repeating what I'm saying as a question back at me. And then eventually you end up, if you get a reasonable session, sometimes it goes off track, but you can go deeper and deeper and deeper into something. So it's a very simple sort of natural language, turn the last sentence into some sort of template of question. But this really convinced people. And he was shocked by this. This was never his intention. This was the implementation by. This was by Joseph Weizenbaum in 1966. He was just kind of testing to see if we could use these sorts of systems as therapeutic devices for people who wanted, who needed therapy. And he realized that people who he showed the system to really thought that they were talking to a person. And even his secretary at one point asked Joseph to leave the room because she wanted to have this session with her therapist, right? This chatbot. This gave rise to a very famous effect called the ELISA effect, which is this perspective that we as humans tend to see human qualities in these sorts of non-human, in this artificial intelligence, that we haven't seen something similar, so our classification says this must be human because I don't know what else it could be. Yeah. So there was various other developments after that, just to mention. Then there was the 5th generation project in Japan in the 80s, where essentially they believed a lot in expert systems. They believed in the power of logic and rules.
And then afterwards, maybe around the late 2000s, early 2010, there was the rise again of the connectionist sort of view, which is the machine learning neural networks. So what's interesting in this perspective is if you look at it, there's been a fight between the neural side and the symbolic side since the 1950s. And it's swapped about 3 times. That everybody thinks artificial intelligence is a connectionist problem. We have to model things like our brain. And then 2 years later, somebody publishes a paper and says, oh, well, with neural networks, you can't model an exclusive OR gate, so it's useless. And then everybody's doing expert systems. And then after a while, there's some success with some neural network, and it keeps swapping back and forth what people think is the way to do artificial intelligence. So this brings us to today, where we have this potential Pandora's box, which is ChatGPT. So a little bit, it's kind of unusual to explain large language models now very briefly because we've heard so much about it. But what is happening essentially is that we're taking some data and we're training for this task here, which is essentially to compute some sort of probability distribution of what is the next word going to be over some context window. So it's not words, essentially it's tokens. It's, they can be sub-word. We can have various tokens in a word, but this is the main concept, yeah? So we have some sort of neural network, in this case transformer, and we're training this for this task to try to predict what the next word in some sequence will be. And then we have ChatGPT over this, which is essentially using people to reinforce using this large language model, which is GPT 3, 3.5, 4. It takes this in, and then it starts to, it has this other model, which is basically learning based on human responses, what humans like as a response. Yeah? So this is essentially ChatGPT then. Yeah? So there's various large language models available. More are probably coming out. Some of these have been released in the past few months. There's even more than are mentioned here. We have Palm, Llama 2, Pangu, Sigma, ChatGPT, and Bloom. So I believe of these, Bloom and Llama 2 are open. Yeah, people can go and they can download these language models and start to use them. Llama 2 being, I understand, the most recommended one if you want to start doing things with large language models. So returning then to the topic a little bit of the keynote, the title of the keynote. The question is, how does all this relate to what I said originally about the motivation for the symbolic approach in structuring everything? Where I said, basically, we need to structure everything because machines are not very good at all at understanding unstructured or textual information. So in that course, I give students a bunch of questions that seem like they should be easy to answer the web. If somebody wants to try to answer this question, feel free. So the question is, what Turing Award winners were born in Latin America? So if you want to try to find out that information, feel free to have a look on the web. I put this into ChatGPT, and ChatGPT has given me the following answer. Yeah? So it has said, basically, as of 2021, Adolfo Guzman Arenas is a Turing Award winner born in Latin America. He was born in Guatemala. He received the Turing Award in 2002, along with his colleague Manuel Bloom, for their work on computational complexity theory and the development of the concept of a proof system. This is not, so let's see. Do we believe ChatGPT? Some people say yes, some people say no. There's also the framing of this question. It's like, in this part of the talk, will I give an example where it's good or it's bad? Okay. So then it continues. Please note the information might not be current and so forth. So, okay, that's GPT 3.5. So let's try the one you have to pay for, so maybe it's a bit better. GPT 4 tells me, as of my last update, there are no Turing Award winners. Turing Award being the Nobel Prize of computer science, of course, I guess we all know that, but states that there haven't been no Turing Award winners who have won, and goes on to explain a bunch of stuff that I don't care about, that I already know. And then ends with, it's getting more diverse, and eventually maybe this could change in the future as the field continues to evolve and diversify. So do we believe ChatGPT in this case with GPT-4? Right, okay, so we're not sure. What's interesting is that this was the part that I found super impressive with ChatGPT, its ability to generate syntax, to generate code, to generate queries, to generate structured syntax. So then I asked, can you give me a Sparkle query for Wikidata to find Turing Award winners who were born in Latin America? I don't know if you've tried this, but you could give it a try at some stage. Use GPT-4, and GPT-4 gave me the following query. So maybe some of you are not so familiar with Sparkle or with Wikidata or querying Wikidata, but we can try this. We can see. Okay. Another security concern. That's very... Okay. Oh, no. No, it's the browser is cutting off the fragment. Uh-oh. Let me see. That's not good. I have no way to do that. I will need a couple of minutes because something has happened with my slides. I need to just swap my deck, but I can continue trying to talk a little bit while I do that. The slides have cut. I don't know what happened. It's like the slides are... I could, that's not a bad idea. It's not a bad idea. So the problem is actually that the slides end here, and I have no idea why. This is like halfway through the talk. So essentially, what we'll do with that is check what happens in Wikidata when we query the Wikidata stuff with Sparkle. So, okay. What would be the easiest way to do this? Would I share on Zoom, in Teams?
Can you try to share again?
I could try to upload a different version. So if you're waiting, it'll just be a couple of minutes while I upload the other slides. You can try to find out what's the answer. So the question again is which Turing Award winners have won a Nobel Prize? Sorry, which Turing Award winners have been born in Latin America? Like maps. Which one's the most recently modified? This one, but that's the file I have. No, it's not the one I have. I'll just upload this one and then take it. So, my bad. Session connect. So the file is like 20 megabytes or something like that. I'll just copy it to the web and give it a short name so I can quickly grab it again. So this is what I copied before and the new one, just to double check I don't make the same mistake. Where's the, let me see the modified date. So this is 2022, 340, 339, 340. So we're back. The audio is back on. So I'll. No, it's. Cheers.
Sorry.
Oh, nice. Okay. It'll be faster. It's okay because I'm going to go to Wikidata. Okay. So did anyone get the answer? What does it say? I can't see. No. Does it say they were born in Latin America? Turing Award, is it? Or? No, sorry, in Latin America. That's Indian. But anybody get the answer? Yeah, Manuel Bloom. Yeah. So I give this to the students, and they look through the list of all the Turing Award winners. Well, also you're Venezuelan, so he was born in Caracas in Venezuela. So Manuel Bloom is the only answer. But the students essentially they have all sorts of hacks for these queries if you ask them. In their case, what they do is they go through all the list of laureates, of winners of Turing Award, looking for Spanish-ish looking names or Hispanic names. So his name is not Hispanic either, but Manuel is sort of, yeah. Okay, so let me see. Apologies here. Yeah. So here I have the query that was generated by STRG, I guess is control. I haven't seen that before either. And this is the query that was generated by ChatGPT. Okay. So we see that it's pretty close, but there's a couple of problems with this query. Which one of them is that I forgot to copy the last brace. I was surprised by that because all of the queries I ever got from ChatGPT were syntactically valid. I don't know where this character is. I'm just going to copy it. And okay. So let's have a look at what it suggested. So we get a query, it doesn't return any results, and we know we should get Manuel Bloom. If we start looking at the query, we see this is the query generated by ChatGPT for the prompt. We have award received, which is what we're looking for. We have here, rather than the Turing Award, I've looked at this before, we have Alan Turing. Okay, well, you can see how it made the mistake, so we should quickly correct that. Turing Award. Let's get the right queue, not too far off. We have this award date, which we never asked for, and it actually says end time, and these things don't have end time, so if I leave this, we'll get empty results, so we remove that. We have person, birthplace, place of birth, yeah, birthplace, and then we have birthplace, continent. Continent, tell me please, hello? Big Brother. Okay, that was a nice tension. Wikidata was building up the tension for the. So we're going to put Latin America. So there is an issue here. Although continent looks pretty good, the birthplace could be like, it would be in this case Caracas, which is actually not going to have that information. So we need to add the country of this place. And I've practiced this before. The first time I did it, it took me about a few minutes. It wasn't that much to fix this query. And continent, because Latin America is not really considered by Wikidata to be a continent, it's rather more like a region used part of rather than continent. Let's see. We'll probably maybe it'll time out now or something. Sometimes it's a bit slow. And there is a faster version of this query, which I'm just going to do just in case. So if you're familiar with Wikidata, you know it uses qualifiers. And we don't really need qualifiers here, so we can just get what's called the truthy version of this, which might speed things up. So as you see, there's still work to do for the people who work on symbolic stuff. People who are working on query optimization, there's still important problems to address. We're going to try to run this. Oh, okay, this worked in the end. So we get our answer. We get so we confirm Marty Bell's answer that Manuel Bloom was born in Caracas. He later went to the US. He did cryptography theory and had various contributions there. He was also involved with, has anyone heard of Manuel Bloom before? He's also known for being involved with the CAPTCHA people, which has some sort of relation to the current talk as well. Yeah. Okay. Cool. Shift F5. Okay. So, moving back to, yep, thank you. So moving back then to the talk, the question is, what about this idea of having ChatGPT generate Sparkle queries rather than trying to answer things correctly or directly, because it seems it doesn't do a particularly good job of that, right? So if we could somehow get ChatGPT to combine this with knowledge graphs, then we could have something like a dream team, yeah? So we could turn from ChatGPT from something like this to, I edited the graphic a little bit to add some graphy stuff in there. It has some graph GPT or chat, I don't know. GE graph GPT, I don't know. So, okay, if we think about this, and this has also been mentioned before in previous talks, the various limitations. Luna spoke about it. Marco spoke about various limitations as well. Here I have like a summary of some of the positives and negatives of the two different technologies or paradigms. And this is, we're talking here about large language models and knowledge graphs, but we can generalize this to neural approaches, connectionist approaches versus symbolic or logical types of, or knowledge representation types of approaches. So what do we have here is the downsides of LLMs. We have hallucinations. We're all more or less familiar, and we've already seen that it invented earlier ChatGPT. GPT 3.5 invented this person from Guatemala who had won a Turing Award, and that person never won a Turing Award. But it mentioned later Manuel Bloom, who did win it, but as a colleague, as a footnote, which is kind of strange. Opaqueness, which means basically it's a black box. We can't really explain why it generates these answers. Intransigence, by which I mean I want to say if it's incorrect, there's not much you can do about it. It's not going to change its mind very easily. You can't really force it to have a different answer. Staleness, because as we saw at the end, September 2021. So it can become stale because it can only reflect the information up to the training. Training is done in large batches at the moment. Bias, costs, so costs of inference, costs of training. We're all more familiar with that. There's other ethical costs as well, the people who are labeling these data and removing abusive content and so forth. Short tail, so it's not good. It's great for like pop culture and this sort of stuff, but you ask it questions in astronomy, it completely doesn't know what to tell you. Sanitized, which is obviously a positive, it's sort of a strange one, but it can be overprotective somehow. You might have legitimate reasons for exploring more controversial topics, and it will just back off and say, I don't want to talk about this. Non-determinism, by which I mean that the response can be prompt dependent, it can be time dependent. A lot of people were saying ChatGPT got dumber from the start. I don't know if people noticed that as well, that they seem to limit somehow the computation time. So then we have some aspects where large language models maybe are better, and the main one I see is usability, that people like using ChatGPT because it speaks to them in a human language, yeah? And factual only, so by which I mean there are lots of questions. If you look at the most common questions in web search logs, the ones that are available from back in the day but should still roughly apply, it's like a recommendation, or how do I do something? How do I tie a tie? Yeah, or could you recommend a book about something? Yeah? And knowledge graphs can maybe help in an indirect way, but not in a direct way with these sorts of questions. Yeah? So they're more for factual information. What about the combination of knowledge graphs and large language models? We don't know. We could be optimistic and we could say, actually, knowledge graphs and large language models will take the best of everything here. And this, by the way, here in knowledge graphs, one could maybe argue. We could have debates about these points as well. Maybe some of you disagree with a couple of points. That's OK. Yeah? It's more an intuitive argument. So for knowledge graphs and large language models, we could then say somehow, OK, what happens with the combination? So do we want to be optimistic or do we want to be pessimistic? If we're being optimistic, we can take the best of both. Or if we're being super optimistic, we would put thumbs up all the way down, and we should immediately leave and go work in this because this is going to be huge. If we're pessimistic, we take the worst of both, that it's sort of like it takes the worst of knowledge graphs and it takes the worst of LLMs. But I think a reasonable approach would be to say somehow we take the best, yeah? So that somehow if we had a good combination, we could address at least these columns or these rows here in green, and we could have green here as well. Yeah, so we could have a sort of complementary way of putting all this together. So I'm going to give a very brief overview, just some pointers, because I wanted to understand, are there people working on this already? What's being done? So Luna, I think, presented work that they have been doing, the various works they've been doing. I wanted to get a broad, quick overview of what's going on in this area. So here's my formal methodology. I put some search into Google Scholar not on the plane, on some train or something on the way here, or before. So these are the kind of different high-level categories I came across, and the references are at the end of the slides. I'm not sure if we'll publish the slides later, but I'll also go through them so that you can check them out. So these are main categories that I identified. So training models that combine KGs and LLMs. So somehow models that are not just language models, nor are they simply knowledge graph embeddings or knowledge graph models, but somehow they combine both in some way. Decoding LLM knowledge as KGs, so trying to get the stuff that ChatGPT seems to know into a knowledge graph, into a graph format, trying to extract that information. Verbalizing KGs using LLMs, so turning a KG into an explanation in natural language. Hybrid KG LLM tasks, which I've separated from what comes afterwards, because there's sort of this crossover. Question answering is sort of different for knowledge graphs. It's more factual. But there's also like more natural language processing type question answering, which can sometimes use common sense, sort of reasoning and so forth. So there's somehow a cross between these two. Then we have LLM-enriched knowledge graph tasks, where we take large language models and we use them to improve performance on known knowledge graph tasks, like knowledge graph completion, construction, summarization, and also some work looking at various tasks where the benefits are. There's even surveys already of this, which I was quite shocked to find. I'll mention two of them. So where you see asterisks, and if you look at the years here, you'll notice there's a lot of 23s. Where you see an asterisk, it means archive, so it's not been peer-reviewed. Yeah? So this is really something where I was looking and I was just finding more and more papers in the last 5 months on archive. Yeah? So we have surveys, discussions, and experiments. So this is all like kind of emerging now. So if you want to look in more detail at this, there's 2 discussions, high-level kind of almost surveys. This is one that's on archive, unifying large language models and knowledge graphs. It talks about 3 aspects, where it's basically you have an LLM and you improve it using a knowledge graph. One where you have a knowledge graph and you improve it using an LLM. And the third is where you have somehow a synergy. It's not that one is secondary to the other, but they're somehow being hybridized, for example. So this is one that's more high level, specifically on the topic of enhancing large language models with knowledge graphs. So KG enhanced LLMs here, or KG enhanced LLMs here, this part here. You can find another survey again on archive, not peer reviewed, but it's an interesting kind of overview of some of the works that have been there in terms of using knowledge graphs to enrich large language models, where we can do this enrichment before training, we can do it during training, we can do it after training. So you can have a look and see there's various ways. Just to give an idea, for example, rather than using the words, we can use maybe some sort of entity linking approach. When we saw Turing Award earlier, it interpreted as Alan Turing. So we can inject knowledge about, okay, in this text, Turing actually refers to the Turing Prize, and give the Q code for this as a token to the model. So with all of this work, I'd like to maybe give my perspective of something I think is very promising, kind of within these works, or maybe as a more high-level direction, is that large language models can make knowledge graphs more usable. This is sort of my perspective of where I think we have the most promise in this connection. So as we saw earlier, this is easy to write. I mean, if you want to write in a natural language, this is quite easy to write. This is very difficult to write for a user, right? And it seems ChatGPT, it's not perfect, but it wasn't really trained for this either. We could fine-tune this. The problem is the data. Where do we get pairs of questions and queries over a certain data set? However, we could improve this. It wasn't designed for this. This is just something it seems to be able to do amongst many other things. So it would be great to be able to use ChatGPT as an interface to the knowledge graph, for example, to be able to generate structured queries. And there's been a lot of work on this, under QALD, QA, question answering linked data, or KGQA or QA-KG, question answering over knowledge graphs. A lot of approaches take this direction. A little while ago, I did a survey in a paper called Semantic Web 20 years on. So it was looking at 20 years of the semantic web and asking people what they thought were the main issues or challenges or problems. So I asked for success stories, I asked for problems, I asked for what's their interpretation of what's happened before. This is essentially a question. There's 10 issues here that were listed in the response and was sent to the Semantic Web mailing list and in other venues where the Semantic Web people inhabit. What we see here is if we have dark blue here, it means that people are really worried that this is something, that the Semantic Web, it's holding the Semantic Web back. So the darker the colors here, the more concerned people are about this. So the three things people are concerned about were unreliable publishers, this idea that data quality issues, that the data are not correct. We have lax incentives, that there's not much reason for people to publish something like a linked data set, or what do they get out of it for hosting these services. But the one that they most pointed to as the problem for our area, for our community, was lax usable tools. So they felt that essentially there was too high a barrier for entry for web developers, for common web users to access. Of course, everybody's using the semantic web every day. So, I mean, if you see Google Knowledge Graph and you see rich snippets in RDFA and 60% of websites have RDF in them, it's all under the hood, right? So but this is, people were concerned about the lack of usable tools, and with better tools, we could do more. So, what would be the idea? Essentially taking this large language model development or technology. We can typically talk, let's say in a knowledge graph or in a semantic web setting, we have our data, an RDF graph, a knowledge graph, a data graph. We have queries, and we have some sort of logical representation. And we can also have graph-specific learning, like graph neural networks and knowledge graph embeddings and so forth. But the idea now is that we could use these large language models as a sort of interface to all of the levels of this sort of knowledge graph stack, where the user can chat somehow with the knowledge graph, can talk with it, can ask it to add data in natural language, add the fact that Manuel Bloom was born in Caracas and won a Turing Award. It can interact with the query level. It can say, give me all of the Nobel laureates who have fought in wars. It can also interact at the logical level. So it can extract rules or ontologies. So you could say leukemia is a form of cancer, and then it can add that as an axiom or a rule, an axiom to your ontology, or a rule to your rule base, to your set of rules. So I find this the most promising. So this is sort of maybe my takeaway message that I'd like to get across, that there's a lot of possibility to use these language models to make knowledge graphs usable. With that, if we have this knowledge graphs, we can maybe have a little taste of the success in knowledge graph area that ChatGPT had. Here we have a graph of time taken to reach 1 million users for different online services that we all should know. Maybe some of them, I don't know what Foursquare is. Is it some place rating thing? I don't know. I don't know. So we have Threads, which is the top, Facebook's kind of Twitter clone. Well, Twitter's alternative. I'm being recorded. I don't want to be sued by Facebook people, allegedly. ChatGPT, second. So essentially, it was very, very quickly, it reached 1 million users. And this is because of its usability. You can just log in and start typing stuff and talking in your language and seeing what comes back. So this is quite an interesting thing, and we could maybe get this for knowledge graphs. So to conclude, to wrap up, the first thing with the historical perspective that I wanted to kind of get across is that this whole neural versus symbolic debate, like this knowledge graphs versus, or LLMs versus knowledge graphs, to keep it consistent, this has been going on since the 40s. People are like, the artificial intelligence, what we need are rules, and we need symbols, and we need logic, and we need expert systems. And there have been other people saying, no, we need to model the human brain. We need to build these artificial neural networks. We have these perceptrons. We want to push forward with that. But the question is, why is it one or the other? Why can't we have both? And that's the idea behind neurosymbolic methods. LLMs solve some tasks that KGs do and do not. KGs solve some tasks that LLMs do and do not, so there's some intersection, but there's also some separate parts that both solve independently. LLMs are unlikely to replace KGs, so good news for us KG people will have a job, will continue to have a job for the foreseeable future. At least in my opinion, if we're all let go and made redundant soon, apologies, my prediction was bad. And LLMs and KGs are a fertile research topic, so there's quite a lot of works going on in this area. So maybe within this one message, one particular message within that, the sub-message that interests me is that these LLMs seem to have a lot of potential to make knowledge graphs more usable. Of course, if people are interacting with the LLM, they're going to say, oh, this LLM is wonderful. They're not going to know that there's a knowledge graph behind, but this has been the classic thing of the semantic web. I talk to students and I say, who's heard of the semantic web? And they're like, well, I'm taking the course. Okay, I've heard, yeah. Aside from that, no. And like, who uses the semantic web? No. And then I ask, who uses all these services? And did you know that the semantic web is behind all of these? And they're like, oh, okay. So what will happen in this case is people will see the LLM and they won't see the stuff behind it, but that's perfectly fine. So a couple of shameless plugs just to end. We, together with Ian Horrocks, Lionel Nakagel, and Andreas Hotho, we started a new journal called Transactions on Graph Data and Knowledge. I wanted to open it for submissions today or before the talk, but I didn't get time. But it'll be open soon for submissions. The idea is that it will be diamond open access, which means that you won't have to pay, readers won't have to pay, and we can publish papers and have data and metadata surrounding this. So if you're interested, have a look at this. Very welcome all the sorts of topics if you're interested in doing research to submit there. And we're going to publish with Dagstuhl. That hasn't been confirmed yet. We're currently in the negotiation process, but everything is going smoothly, so we hope to be published by Dagstuhl, which is, allows us to be free to both authors and readers. And yeah, the knowledge graph book. You can get this knowledge graph book here if you're interested in knowledge graphs. We didn't have too much on language models, large language models. It was hard to finish around 21. It would probably be the first topic we'd have to add, but it's a free book. You can grab if you're interested in knowledge graphs. So with that, I'll go back to my, as well, references. These are the notations you saw on the slides. There's about 30 papers there. Yeah, that's my talk. Thank you for listening.
Thank you very much for a very nice, very active talk. We enjoyed it a lot. Questions?
Yeah, hello. Thank you for your talk. So my question would be, do we need to do something to our beautiful knowledge graphs to make it easier to be integrated into LLM? So do we need to apply a specific vocabulary, or do the knowledge graphs need to have a certain structure to be able to be integrated into this combination of knowledge graphs and LLMs?
Yeah.
Thank you.
So thank you for the question. Yes. So the main thing you would need if you want to integrate your knowledge graphs with your LLMs is the ability to take text and to identify in the text what elements of the knowledge graph are being spoken about. So there are techniques for that are called like entity linking, for example. So you would need the elements that would enable that, which would be, for example, labels of the entities, maybe lots of aliases. So you capture, for example, different ways, Alan Turing, A Turing, Turing, all the ways you might be referred to in a text. There are ways in which you can help your entity linking tools to generate this. Obviously, as well, in the languages, if you wanted to be multilingual, you need multilingual labels. So the main aspect would be, I would say, to enable the matching of text. You might need to add some elements to your knowledge graph to ensure that, given some text that the LLM will be trained on, that you can connect the text and the symbolic representation. That would be the main part. And then after that, it really depends on what application you would like to do.
What you just said basically summarizes my feeling with connecting it. The one thing I really found cool is I had the impression that for the first time it makes sense to have really nice vocabularies with good labels, good descriptions. I feed it some input to it, and it gave me absolutely amazing answers based on that, which is probably even with just vector models possible, but this is for me the first time that I really thought it makes sense to have these things for the machine and not just for the humans.
Yep. So it's been useful. I mean, people have been working with entity linking and sort of connecting text with knowledge graphs and annotating and semantic annotation of documents for a while. But now it seems to be a strong use case again, and more motivation to get lots of labels, lots of aliases, lots of languages in order to have this better fusion of KGs and LLMs. Yeah. Thanks.
Thanks for the inspiring talk, and thanks for including my paper there. Where do you see the most benefit or the most potential in the combination?
So I think it's mainly, as I mentioned, I would say usability. It's just like interface somehow. This is what interests me. What will be the most commercially successful, or what would be the most successful in terms of research? I'm not so sure, but I see it as a way that it's the usability, that you can actually start to get people interacting with knowledge graphs through natural language interfaces, which was always a dream in the semantic web. But it was always, there was controlled vocabularies, and you had to write your thing this way or that way, or half the time it wouldn't work. And it really seems now that it is feasible that these natural language interfaces we can start to develop and have them for data, rules, ontologies, queries, and so forth. So that's
Exactly, and some specific task you really want?
Of the ones I mentioned before, let me find this here. Like which one you want to work on? You're asking me what should I research on? Is it okay? Let's have a look and see. I think, I always like the elegant approaches. I always like the approaches that somehow move us towards the solution, which maybe sometimes doesn't exist. So I find the hybridization of knowledge graphs and LLMs interesting, where you have models, you don't sort of separate them, but you have some sort of models, you have some models that capture the knowledge of the knowledge graph, and they capture what large language models, whatever it is they're capturing from the text. So I think this tighter integration rather than separating them is very interesting. But for the meanwhile, I guess, you can also get a lot of, there's a lot of different approaches here and so forth. I think one thing that's more short term that could be very interesting is what I notice a lot is the issue of ChatGPT not knowing the Qs. The Q values. It knows all the properties and so forth, but to be able to integrate, and there's already work on this, to integrate tokens or IDs from the knowledge graph into the training so it can recognize that this Turing award here is the same as this Turing prize here, and it can somehow, you have more semantic tokens rather than the sort of lexical tokens. What do you think what did you work on? I'm not sure which paper was yours. Which of these topics did you work in?
It was a summary on the ChatGPT different tasks.
Okay.
And we included their Sparkle, which I probably want to go on with.
Yeah. And which task do you think it would be?
Maybe the text-to-Sparkle generation.
Yeah, I'm also kind of working or dabbling in this.
Easy tasks.
Yeah, so I'm also working a little bit on this. I agree as well. Yeah, I think that's a very cool task. Yeah.
Thanks.
Yeah, thanks for your talk. I'm just having a follow-up question for your first answer. The question answering community is still struggling with this lexical gap, like enriching entities with additional labels. Do you have a suggestion to that, like how to automate that?
I think there's multiple approaches. It depends on what domain you're in. If you're in a very specific domain, it's going to require some work. Yeah, so I don't see, maybe there are some techniques where if you have a related corpus, you can maybe use some techniques to try to do something semi-automated. So the one question is what domain you're in, then the second question is what kind of quality you're expecting. Do you want it to be really precise or not? Because that determines the manual versus automatic approaches. Assuming you want to be precise and you're in a very specific domain, it will probably involve human-in-the-loop type endeavors. But if you're in other domains, you can also use a lot of existing corpora. So for example, you could link your knowledge graph to Wikidata, DBpedia, and then you can use that somehow to extract the lexical values that are there. And it's not that you have to link it, but often Wikipedia, DBpedia, they have lots of keys. So if you have a key in common, you can find out all these labels, so you can exploit these existing resources for that. If you have tolerance for lack of accuracy, or if you're in a domain that's more well known, then you could use some automatic methods to help with that.
Yeah, I'm surprised that like ChatGPT is so bad in entity linking, because basically they have all the information, and linking Turing Award to Alan Turing is like, yeah, it's a no-brainer.
Possibly. I mean, that's harsh, I would say. It wasn't trained for that specifically. So it's also very good at the Ps. And I think the problem with the Qs, the entities, is that there's 100 million entities on Wikidata that it has to recognize. And this has been a problem in question answering over knowledge graphs for a while, or text to Sparkle. So I think you could easily take one of these language models and fine train it to get better at that, finding the entities for Wikidata. The Big Brother Latin America, I have no idea what that was about, but okay. Who knows?
One more question? Sorry. I'm sorry.
Hi, thank you for the talk. Do you think knowledge graphs could generate some kind of synthetic data for transfer learning of the upper layers of LLM, so we don't have to make these huge prompts?
I'm not sure I understood actually before you go. So could you?
Yes.
Yeah, could you repeat it again? Sorry. So I understood a different question, and then you said something at the end that changed the question.
Okay. So the idea is, now when we do prompt engineering, we sometimes have to stick in part of a knowledge graph to get an answer in that. But it's expensive. So what if you could do transfer learning, and the knowledge graph could sort of make synthetic data for that transfer learning, so you could have a version of the LLM?
Yeah, so there's been work in kind of both aspects, right? That sort of prompt enhancement using knowledge graphs, but also in terms of the text enhancement using knowledge graphs. So you can enhance, you can use your knowledge graphs to enrich your text. So there's been works that have done it's a slightly strange approach, but it makes sense, which is you verbalize the knowledge graph using an LLM, and then you feed that into the LLM to generate textual information about your facts. It would be interesting. What I don't know is if it's going to help a whole lot. If you take, for example, Wikidata, because Wikidata has to be referenced, and if you look at most of the references, they point to the web anyways, and at the level of an individual statement, you will probably find that information elsewhere. What's interesting about Wikidata is it's structured, and you can answer a query over the entire collection of Wikidata, but I'm not sure that there's that much novelty in the individual facts in Wikidata. But if you had a domain-specific ontology or knowledge graph, there could be, or maybe a corporate or internal knowledge graph which contains some information private to the proprietary or private to the company, then that could be interesting, but you'd have to do that obviously in your own machines with, yeah.
Thank you very much, Aidan. Let's have a big plus. So. We can carry on the discussion and the break, which is until 10:30, but I want to also mention that at 12 we will have a 10 minutes swap of the rooms, so please don't forget that. And then see you in next sessions. Thank you. Oh, Aidan, you're 3. Oh,